Hello, my name is Yasser and I'm going to be talking about the role object pattern. So the intent. So the intent for this is to it adapts an object to different needs of the client through role objects, and then each represents the role that the object has in context of the client, and it's set up dynamically to keep the system configuration simple. Motivation. Abstraction is the main reason we use the role object pattern, which is basically hiding the main implementation, just showing a simple method without knowing how it works, which is basically what the user does, just making sure that they get the right values that they need, and they don't really care how it works as long as it does. If the role object pattern is useful for scaling applications and ensuring abstraction is still being done properly, the role object pattern suggests to model specific views as role objects, and then each one can be dynamically attached or removed. We'll see how that works through the UML diagram and also the program that I wrote. And we have creating subclasses to allow for clear scaling, which could work. However, this implies that a person cannot be two things at the same time. Think of a lender versus a borrower. Those are two different objects. A person can't be a lender and a borrower. The role object would be a main class of two subconcrete classes. For instance, back to the borrower and lender class, we have the role object as the customer role class, and then that holds a reference to the customer core class. And then there's also the lender and borrower concrete classes, which implement all the customer role methods as well as their own private methods. So applications and known uses. The role object pattern is used whenever a programmer wants to scale their program while keeping abstraction. So they just want to keep that in mind because that is one of the fundamentals for software design. For some reasons to use this pattern, they want to handle abstraction in different contexts, don't want all the interfaces in the same class. They have dynamic roles that could be added or removed on demand to allow for flexibility, or if they want to keep roles independent, so if one is changed, it won't affect the others. One of the three principles in object-oriented programming is abstraction, which basically means that the programmer hides the relevant data, and then this helps reduce complexity and reduces or increases efficiency. Then this pattern is really effective at abstraction. So some consequences. We have the advantages. The application gets better decoupled since concrete classes are independent of others. Changing one won't really affect the other. We have roles are independent of one another. They can easily be attached or detached, making it more abstract and organized. So, and also it keeps it a lot cleaner because they don't have to keep creating or keep adding to a specific class. They can just add a new role object. And then we have no need for multiple inheritance since there would be multiple roles, the subclasses. However, there are some trade-offs to using this design. Client or concrete classes could get complex, and then since each time there is a role, the client needs to check if it has a part in it, and then it has to be done across all the different clients that they have. Maintaining constraints between roles gets harder since each subject has objects it depends on, and then makes scalability and consistency tough. Constraints on the roles aren't enforced by the type system, meaning that if one role depends on the existence of the other, the program won't really catch it until it's up and running. So this could cause a big problem once it's something you don't really test for, and then once you push it to production, people start having this issue. It could become a hassle. So this is just the structure of it, the UML class diagram. We have the component, which is the superclass that gives the specification for the concrete role class. We have the component core, which is the interface implementation of component, and it has the instances of component role. This manages the role objects. Then we have the component role, which has the reference to the component core, and it implements the interface for component through the component core. Then we have the concrete role, which implements the specific extension from the component interface. Then we have the different concrete roles. Those are the ones that get added or removed depending on the role that the object plays. So here are a few snippets of code. The first one is the worker. This worker is the component class. Basically everything's abstract, so there's no implementation for any of them. We have the boss class. I called it boss because this guy is basically the boss of the workers. Right here it just goes through, adds the values to the worker list. Different values. We have the name, we have right here, we have name, this is the age, this is salary, and then if they're employed or not, and then these are the different roles. I created the architect, the doctor, police officer, firefighter. Then this one just goes through each one, adds roles, adds roles and gets roles. And then this is the worker core implementation, which is the component core. We have, these are the different, these are set in the constructor passed from the boss class. We have the roles array list. So we have this one, just I have a function that gets the index, just right here, just basically loops through instead of overriding the equals operator. And then we have this one overrides the operator inside of the worker core, or the work class, the worker class. And then this one removes a role. It is a void, but it has a the way I set it up was once it removes, it just says that that role was removed from the list. And then, yeah, if this doesn't get hit, that means there was an error. However, I did test it extensively and nothing really happened, so it should be okay. We have the has role. This one just returns if the user has a role or not. Basically, just checks the list, gets the index, and then through index, if it's -1, then it just returns false. If it's not, that means there's a specific index in there, or the index is different, meaning that the role was found, so it does return true. And then we have the get name, get salary, get age, get work status, set state, and we also have get state. Get state and set state I didn't really use much, but they were part of the UML diagram. It just depends on however they want to implement that inside the code. I just didn't really find a need for it in my specific program, but it could be, I could see it being very useful in much larger scalable programs. Okay, so this is the worker role implementation. This basically is the component role. This one has the concrete roles in them. And then we'll take a look at those. This one just returns the different roles, the different methods. Well, not really methods, it returns the worker core. And then these are the different classes. Let's see, it has, each one extends worker role, and it does worker core.getName, which is all these methods are here. And then I'll put jobs just so that we know that it hit the object properly, if that makes sense. We'll take a look at it. And these are just some references. So we'll start with the boss. So boss right here just creates a new component core, worker core, adds these different values as I said earlier. We have the different roles. We have doctor, we have architect. This one just goes through the list, gets each value, and then it adds that specific value. That's pretty much all it does. And it does create this list, which is used inside the main function, because the main function extends boss, and then it uses that list here. So the main function basically, so if the worker has, each value inside the string, if it has a role, I have the different ones: architect, doctor, police officer, firefighter. And then right here is just typecasting, and then it does age, name, salary, and then work status is a boolean. Instead of just putting 0 or 1, I had it so if it's true or false. Let's take a look at it. And each one is implemented the exact same way, except we have different roles with the doctor and the other ones. Oh. Okay, so this is my name is John, I'm architect. This is the age, name, salary. He's employed, employed, employed. And then this one is, oh sorry, these two are unemployed. And then we have this one. I decided to remove the role, and this works for every single one of them. Doesn't really matter. Let me just move this down here. And then removing the role does work for every single one of them. This is done right here. No, sorry, it's the wrong class. This is done right here. So police officer remove role, and then it just prints out an empty line. So, and then once the role is removed, it does output on the screen that the role was removed. Basically, these are the different implementations. Well, these are the abstract methods, and then each one gets overridden in the worker core. This one's a pretty long class, and as this one just checks if the array. Oh, the array list right here. Where is it? Right here. The roles. This one just keeps track of all the roles inside of that specific class, basically. And then this is the object that's used, because you can have multiple roles. So then we have, this is the worker role. This is worker, I already explained that. We have the architect, which worker core, which calls right here. We have worker core, extends worker core. Or worker role, sorry, not worker core. Worker role. And then worker core does have, worker role, sorry, does have this method, the worker core method. And then that's where worker core get name. Technically it calls it from worker role, and worker role calls it from worker core. So basically these never really interact with worker core. And then you can just change these to pretty much anything. We can change the output job to say whatever. Then we can also add another let me just copy and paste this. Oh, actually, I mean, I don't know if it's really necessary, but we could also remove this one actually instead of, because it's going to take a while. Well, not a while, but there are a lot of things to change if I want to add one. So let's see, ff.remove role. Ff is just the local variable. Remove role. We have the string spec. We want to remove firefighter. Doesn't really matter because I have it, so it just ignores uppercase and lowercase, so they don't have to be exact. Oh yeah, and let me, actually, I should automatically do it, so we'll run it again. And then see, firefighter was successfully removed. But yeah, this does happen after after they're added, and then checked if it has a role, then it removes them. It doesn't recheck it, but the thing is, if we put it before, then I don't really have it checked, so I'll check for before. Like I don't have that check for nulls and stuff, so that could be if I wanted to scale it a little bit. But that's pretty much how the object role works in essence, and you can see it's very easily scalable. We can add different classes instead of architect. We can also add like an engineer, a computer scientist, pretty much anything, and then all these would stay exactly the same, which is pretty nice. It's pretty neat. And all we'd have to do is just declare it in here, and then just pretty much add more of this, and then inside main just have another little block for it. But yeah, that's pretty much my presentation, and thank you.